Hi there. You know, occasionally I like to do some maths, and today I just wanted to show you that the iterative method for finding the square root of real numbers works just as well for complex numbers. For those of you not familiar with the scheme, I've inserted this slide here. You can see that we take y equals x squared and we're trying to find x for a particular y. You can solve that iteratively using the equation at the bottom of the page. You put a guess for x, xn, into the equation. It'll give you a new estimate, xn plus 1, which you can then put back into the right hand side of the equation and keep going until you get a converged answer. In practice it looks like this. Since 42 is the answer to life, the universe and everything, let's see what its square root is. Switch on the calculator, make sure the memory is empty. Say 42, well 6 sixes are 36, so that's near enough, so we'll take 6. Take that as the first estimate by adding it to the memory. Then we'll say 42 divided by the guess plus the guess divided by 2 minus what's already been guessed, and then add it into the memory to replace the original guess and start again. 42 divided by recall memory plus recall memory divided by 2 minus what the current guess is, and then add the difference. See, the difference between the previous and the old and the new guess is not too bad. 42 divided by recall memory plus recall memory divided by 2 minus. Now we're getting there. Ah, that looks good. Let's see what we got. 6.48074005 multiplied by itself is equal to almost exactly 42. Not bad for just a few iterations. If we put this scheme into a spreadsheet and use a really bad guess for x, let's say 3, you can see even with that it finds the square root of 42 within 4 or 5 iterations. Curiously, the same scheme can be used when finding the square root of complex numbers. As you can see from this slide, y now becomes real part a plus b times the square root of minus 1, I. And similarly, the solution is x is equal to c plus d times the square root of minus 1. Of course, square root of minus 1 doesn't really exist because minus 1 times minus 1 is plus 1, and plus 1 times plus 1 is plus 1, so there's no such thing as the square root of minus 1. That's why we call it imaginary. However, I can still use exactly the same iteration scheme as you can see at the bottom of the page. I just have to substitute the imaginary and real numbers into the equation. Of course, doing this with complex numbers is slightly more complicated than using real numbers. You have to remember these tricks. That I squared equals minus 1. Square root of minus 1 times the square root of minus 1 equals minus 1. And also, if you take c plus di and multiply by its complement, c minus di, that turns it into a real number. Now, using these tricks, you can then substitute into the equation. Just to be irritating, I won't do the derivation for you. I'm sure that you can do it yourselves. As it says in these maths books, the solution is obvious. So combining all these equations and definitions together and separating into real and imaginary parts, you'll get the iteration scheme I've shown on this slide. What you do is you take the current estimates of C and D, substitute them in both equations and get new estimates for C and D, which you then insert back into the right hand side, going round and round until everything converges. Finally, with a bit of luck, you'll have square root of y is equal to C plus D times I. So we can implement these equations into an Excel sheet. As you can see on the screen, I've taken y as 9 plus 15i and initial guess for xn as 7 plus 9i. And then step for step the iteration gets us close to the answer. As you can see, by the time it's at iteration 5 or 6, it's converged to the correct answer. Just for fun, I plotted the real against the imaginary coefficients to show how the scheme converges to the right answer. Curiously, if I use the new estimate for Cn directly to calculate the new Dn, as on the right, it stays stable and even gets to the answer slightly more quickly. Isn't that amazing? Just as for real numbers, there are two solutions to the square root, where you simply change the signs of the real and imaginary parts, and or you can use this iterative scheme by starting from a different starting point, as you can see in this spreadsheet. Well, I hope you found that amusing, and congratulations on making it all the way to the end of the video without falling asleep. Until next time.